Hello, everybody. I know that not a lot of people will be here yet because this is our second live stream ever for Entire. I'm going to go ahead and probably ping Discord as well as a few other places just to let them know, like, hop in, join in. Give me a quick second to get that done. If you are actually tuned in, tell me where you're tuning in from. I would love to know. I'm in the Boston area right now in Boston, Massachusetts, but I'd love to know more about where you guys are tuning in from. So I'm just going to grab this link really quickly and drop it in the Discord and then tell people I'm live. So, hey everyone, we are live. And I'm going to do it at everyone. Come hang out with me. And then also to my Twitter. Hey, you're in Paris? That's so awesome. Thanks for tuning in. I know it's sorry, I just muted myself. I know it's probably the evening, so thank you for tuning in on your evening. I'm also going to put on Twitter. We're live as well. And let's get into this. We're live. Come hang out with me. All right. Cool. So, for folks who don't know, my name is Rizal Scarlett, and I work at Entire. Hey, Nick, what's going on? Entire is this platform that's really changing the software development lifecycle, and I've been trying to start some of these live streams. Some of them have been like interactive, and some of them have just been like talking through things. So right now, I'm probably just gonna like talk through some stuff. So that people get a better understanding, because recently we launched something called what is it called we launched something called mirroring, and I think like that phrase is not really that like familiar to people, or people might not really understand why we even did that. So just quick background, and then I'm going to go through a slide deck, and then maybe if we have time, I'll show you really quickly how to mirror. But that's what we're gonna do today. So I'll just say hey to people. So hey from Paris, hey to Nick, and also hey to you as well. What do you mean you were just checking? What does that mean? All right. So let me dive straight into this. Recently, we basically, and I wonder if you guys could see this well. If not, let me know. But let me try to like zoom in a bit more. I don't know if it's really working. Not really. Or I will change slides. Tell me in the comments. Is it like too small, too little? Nobody say anything? All right, cool. So recently we launched our own Git hosting platform at Entire, right? And our like whole like claim to fame right now is that it's really a fast Git hosting platform. And just to give you guys context on why you would even need that, is right now, like you might be seeing a lot of like companies and organizations are coming up with their own Git hosting platforms. If you're like, what is a Git hosting platform? That's where you store your code, right? Like think GitLab, GitHub, Bitbucket, right? People are storing their code in these places. And then they're able to do version control, CI/CD, all that good stuff with it. However, things are changing, right? The way Git hosting was initially made, it's not very well supported for agents. Right now, like, or in the past, I was a pretty slow coder. I don't know about you guys, but like I would take a issue, I would take like a couple of days or maybe even the whole 2 weeks to really complete my work. And then after that, I would at the 2 week mark or even sometimes past it because I would be late, then we will get a pull request open. But now when I work with agents, I be opening like mad pull requests. Like you would think I'm like the best engine. Well, no, you wouldn't, but you would think I'm the fast engineer. So I would be like opening like 10 pull requests in one day with my agents. And sometimes that can be very heavy on the traditional code hosting, Git hosting, Forges, whatever you want to call it. It can be very heavy on them, and that often like causes like outages. It might cause like rate limiting. You might see people be like, dang, I can't push my code, like this platform is down. So one of the many things we're doing with Entire is we actually rewrote um like how Git hosting should be. We've taken a completely different approach so that it'll be easier for us to work with agents and faster. And I was nerding out, guys, because I like looked into how we like did the whole storage layer and everything, and I wanted to share that with people. Maybe people will think that's boring. I don't know, but if you're like kind of nerdy like me, you might be interested and how we set this all up because it's really a little bit different than Git itself. So let me just see what everybody else is saying. Hey Eddie, I've been using entire CLI with Cloud Code. Awesome. Have you liked it? Has there been issues for you? Like, I'm glad that it's been helpful so far. Hey from India. And then you said it's great too. Awesome, awesome. And then hey, that's okay that you wrote help everyone. I stay doing typos. All right, so let me get back to this. Um, okay, so what was I gonna say? So first of all, the claim that like ours is the fastest. All right, like we saw what that cursor had their stats and how fast they were, and we're like, let's benchmark it ourselves to make sure that we're not just talking crap or anything like that. Like, let's make sure ours is actually fast. So we use the platform or we use the benchmarking tool called ForgeMark. This is our own like open source benchmarking tool. You can use it yourself too. Let me see if I can even show you guys it and drop it in the chat. ForgeMark right here. Yeah, this is our like benchmarking tool that tells us like, oh, is it actually fast? And what we did find, as you can see here, we were able to do 570,000 clones per hour, 1.7 million clones and pushes per hour, and 2.1 million. Of course, these were not like they were like simulated in a way, I believe, but that's how like everybody's doing these testings now. And then let me drop that in the chat if you guys are curious about that. And then next slide for me. But like I said, I want to talk about like how all of this is coming together, right? It's not We didn't build this in the traditional way because if we did, we would just be rebuilding all of those platforms that we've already used. We'd just be like literally just like cloning Bitbucket or GitLab or GitHub or whatever, and that wouldn't be really actually beneficial. So one of the things that our team did, so we have a repository called EntireDB. This is our database layer. But I learned that it's not one database. It's actually made up of multiple different databases. So we actually split apart two things. We have branches and tags living in PostgreSQL, and then we have commits, trees, files, storage nodes living in like these distributed storage nodes. I think it's really, really interesting because in traditional Git hosting platforms, those are all put together. And they're all kind of treated the same way. And Git is kind of like a little bit of a database, right? It has objects inside of it, and those all point to different commits. And those commits may point to trees and files and different directories. But we took these apart, and one of the reasons that we did that is because we found that like branches and branches and refs are like smaller, and PostgreSQL would be better suited for them because you just need them to like quickly reference a certain point. But things like commits and trees and files, those needed distributed storage nodes because those are so large, and that's part of what often takes really long. And what I started getting really deep into is like, what is even happening in a Git push? because oftentimes like I type git push and I'm like, okay, who cares, right? Like I know it pushed my code up to the repository, but I didn't really think about what was going on under the seat, under the hood. And I think now that like agents are out, sometimes I forget to really think deeply about like what's happening in my development workflow. I just kind of take things for granted. So I was like, let me take a step back and figure out, right? So as I already mentioned, under the hood, Git acts like a database. Specifically, it's kind of structured like a DAG, a DAG. And the commands are kind of, this is how I put it in my head. This is not really like, somebody may argue it's not really exact, but I put it in my head like, okay, the commands are how you're interacting with your database, right? Like you have a git add, you have a git commit, you have a git push, kind of like when you say like create, read, update, or whatever in a database. So you have these commands that are deciding here's how we're going to interact with the data that's stored in our database. So when you do git push, here's what's happening. I think it might be too small for you guys, but let me, oh, here we go. I can zoom in a little bit this way. So first of all, from your laptop, you're running git push, right? Then after that, your client is trying to figure out what history that you have on your computer versus the history that's on like the Git hosting platform, right? Like it's like, does GitLab, does GitHub, whatever it is, already have this line of code? Does it already have this file, et cetera, et cetera? So it has to do that computation. Then after that, it compresses it into something called a pack file. That's just like get data that gets sent across. I didn't go too deep into what a pack file is, but it compresses that into a pack file and asks the server to update that particular branch that you gave it. And it kind of goes through this really interesting flow. After that, the repo folder gets written to the disk, and then the branch gets updated. I don't know why I thought that was cool. I was like, wait, I didn't realize it was going through all of those steps. I just thought like, all right, we're doing a git push. It is what it is. The live stream keeps freezing. Oh no, is it freezing for other people? Please let me know. Is it freezing for you all as well? How long have I been freezing? It could be me, but I will keep going. I'll keep going. Not for you? Okay, great. Thank you, Nick. All right. Maybe it's just you, but I do be having bad internet sometimes. All right. So next thing that to talk about, the problem with the way that the traditional pushes are going, and you might have remembered right here where it says the repo folder gets written to a disk. The issue with that is it's all relying on the same repository directory on one disk, right? So every time the human is pushing or fleets of agents, now things get held up. Because if it's a human and you're like slow like me, pushing like, I don't know, every like I'm doing a pull request maybe every 2 weeks if I have no AI. And like maybe my pushes, like, I don't know, maybe that could be like every 20 minutes. I'm like, oh, finally, I got something working. Let me push that up. Sometimes I don't even remember to like make that commit or push. But sometimes now everybody's all into the whole, let me zoom out a little bit, like having agent fleets running, like having like 20 agents happening at the same time. So now when that's happening, that's putting a lot of weight on that single directory, and it's becoming like a, I don't know, like a barrier or a choke point for all of those agent workloads. So what we end up doing, right, like I already mentioned, is we have two different kinds of data. We have the bulkier stuff and the immutable stuff, like the things that can never be changed, commits, trees, and files contents, all going into like distributed storage nodes. And then we have the branches and the and like things like tags, because those are like tiny pointers. Those are mutable because they'll change, like they'll point to one commit, and then when you do another push, they'll point to another commit, maybe a merge commit. So that's how we basically deal with it. And This is a lot of words. But I thought it was really interesting that like I looked through our team Slack and everything. I'm like, dang, they made this decision really, really early. Because they knew that like putting things in these distributed storage nodes will be able to handle really large volumes, and they knew that something like PostgreSQL will be able to like coordinate the like small frequent updates. So they're like, let's just separate it that way. um but we did realize that there's like issues that can happen. So let me see if this is basically the process now. I started skipping ahead. But this is basically the process in EntireDB, right? So I say I have a git push, it uses the pack file again, it takes all of that data that's getting pushed. And then you have the receiving node, right? The receiving node will say like, is this actually what we want? Is that what we're looking for? And then it'll say, all right, cool. Do we have availability to put this in a storage node? Yes, we do here. And then it'll also replicate it just in case one of the storage nodes are down. So it'll be like, we'll put the data in storage node A, and we'll put it in storage node B just in case storage node A goes down. And we can put it in storage node C as well. And then once all three of them say, yeah, we all got that data, then that push gets like confirmed and goes to a new commit. And like I said, we plan for a couple of things, right? I kind of started talking about what if a node dies, right? Like you put something in a storage node, something can happen, like your network could go down for even 1 second. Or the storage node might restart. So we plan for that. We're like, let's not the push shouldn't work unless both the at least two nodes confirm that they're ready and they have the data, or that they're able to receive the data. And then the other thing that we decided on was how do we handle if two agents push different data up to one branch? Git already does handle this, but the way we handle it is a little bit different. So if they're both trying to like update the same branch but with different data, we're using something that Postgres has built in called compare and set, and it'll like compare what's happening. And if one is trying to override another, it'll like be like, nope, pause, don't even do that. So I'm actually going to pause too, make sure I'm not talking too much. I know this is more lecture style. I figure I will just show you guys talk to you guys about some stuff. Some streams I will like actually be like coding, and some streams I'll just be explaining things that I think are cool. Maybe you guys are like, not really, but let's see if I could get my mouse moving. Oh, you're in Dana Point, USA. Awesome. I didn't know that. Yeah, you're right. The slides are cut out because I zoomed in more like to the areas that I was trying to talk about, but maybe I shouldn't do that. Because look at them, they're small. Maybe it's just me. I was just like, I started talking about the two agents, so I just zoomed in right there. But you're like, girl, I can't read that. You know what? Why don't we go ahead and just push this up to a GitHub repo, and then you guys could watch me do that too. Let's push this up to a GitHub repo and have it running on GitHub pages or something like that, and then you guys can follow along on your own. All right. Where did I put this? Okay, who likes Codex or Claude Code? Like which is your favorite? I'm always curious. Or maybe you like Open Code or Goose or something like that. I'm a Codex fan till I die. Well, until I see something better come out. All right, let me tell it. Can you find what is this? Slide deck that I made in here. I don't know where it is. Let's zoom in. And the awesome thing is I'm actually using, I don't know if you guys can see this, I'm actually using Entire in this repo. So it's going to use the entire search skill to find where I might have made this deck. Uh-oh, it didn't find it. Let me see. Let me make sure I'm even in the right directory. Cloud Code and the Codex Desktop are so different. My brain separates them. Really? And what do you mean, like your brain separates them? Like you use them for different situations? So everyone's like, I love voice mode. It's so fun. It's not for me. I wasn't built for it. All right, so it should be pushing this up, and then you guys can look at the slides on your own. Codex is just an everything app. Like it can browse, it can wield your computer well. Claude Code Agent orchestration is really good. Okay, that's a good point. I think the way you separated it, I can't argue with that. I'm getting freezes now, not sure if it's my computer. Oh my god, I'm gonna rewatch this and then figure out if it's me, like when we're done. I don't know. I don't want to stop the stream to figure out. Let me see. I'm not seeing any. Like usually when my network is bad, StreamYard will tell me. It will say like your connection is booty. You got to do something. But I'm not seeing any sign of that. But yeah. You use both but no voice? Oh my god, are you guys my people? That's great. So it's waiting on the deployment to finish. Okay, smooth on your end. Okay, great. Thank God, because every time I do a stream, it's some other issue. That's actually why I'm putting the demo to the end, guys, of like how to mirror your repo, because the demo gods, they don't be with me. All right, here we go. You guys can get the deck right here. And I'll just post it as a comment here. I don't know if you'll be able to see it, but I just posted it right there. If not, you can go to github.com/blackgirlbytes. Go to my latest repository. You'll see this public repo, and it has the link right here. Thank you so much, Codex. And let's get back to what I was talking about. Move this out the way. All right, so we already talked about this, right? We already talked about the idea around this. Now I lost where I was. Okay, great. So we already talked about like what happens when it get pushed, right? For traditional Git hosting, it just goes straight to write on one repository on one disk. But with EntireDB, we have it stored in either distributed storage nodes for the commits and like trees, directories, all of that you see, and then we put the branches and tags into PostgreSQL. But now, how do we handle things like clones and fetches, right? How does that get faster? Or how did we make that be a little bit faster? So once we have the history inside of EntireDB, we have to think about how do we take it back out when somebody requests it, or when an agent requests it and says, hey, I want to do a git clone or whatever that is. So reads are actually really like surprisingly expensive. For every time you do a clone or a fetch, the server has to figure out which part of the repository history that your machine already has and which part does it need. And that calculation is apparently super heavy. And then agents make this even more brutal because they're starting out typically without a local copy. Like for us on our computer, if this is not the first time we've cloned it, we have that version, but an agent has to be like, wait, do I have this locally? Probably not, whatever. And so it's starting from fresh, and they have to like fetch these updates as they work, and that repeats for like almost every single request. So similar to on the so basically we like rewrote this like engine for ourselves. So basically we did these 3 things. Some of it is a little bit over my head. Like, I don't know what reachability bitmaps really are, but we created reachability bitmaps, memory mapping, and streaming responses. And here's what I found. Like I really tried to like make this make sense in my head about reachability bitmaps, but basically here's how the idea behind it works is that like instead of tracing every link in the history per request, we're basically have a checklist that shows which objects belong to a commit, and then it narrows it down much faster. That's how what my brain was able to get from that. I'm like, I don't know these words, but I think what you're saying is, or I think what the setup is that like we have these pre-computed checklists, and the programming just goes through that. um and then we also have memory mapping. That way, instead of like copying the whole Git data into application, the operating system just does different sections, and EntireDB um like reads it as it touches it. And then in terms of the next part is we stream responses. That way we don't sit there. The EntireDB doesn't sit there and like wait for everything to get written out. It streams it, similar to how when you see an AI agent type out words, that it's streaming it to you because it'll put like one word at a time, so then the data gets there faster. Okay, if people have questions too, let me know. I don't know if I'll have the answers, but it'll be good for me to start thinking about the answers. And then the other thing that we did that like I think our team is super like duper proud of, you might have seen us like say like, oh my gosh, like we have the fastest Git hosting in India and all of that, is that like we decided like let's have every repository in a home region. One of the things that also takes long for like traditional Git hosting is like a lot of the infrastructure is really centralized. So like maybe you're like I'm in France and I want to push some data. Um, even though I have something called a POP, or a point of presence, um, that just communicates that I want to push my Git repository or something like that. But it doesn't. There's no place in France for me to actually do that. So then it has to. My POP has to basically travel, or have data travel over to the US, communicate that I want to like have my data get pushed, and then whatever central servers are in the US are like, hold on, wait a minute, I'm actually working on previous requests before this, so things get held up. But now we decided, hey, why don't we have these regional clustered servers in different countries? These are not like full data centers. Like I think people thought like, oh, you guys are putting up full data centers. No, these are like AWS central like regional clusters that already exist. And we didn't like stand up our own. But basically now your repository and all your Git data can live in that one place, rather than you saying, hey, I want to push my repo or add some data, or like push a commit or whatever, but it has to go over to the US. Instead, it's just like I can store all of this right here, right next to me. And if I want to pull data, like if I want to do a Git pull or whatever, I can also have that come straight from a nearby node. So right now we support, as you can see, US, Europe, India, and Australia, and we're going to expand that to be more. I'm going to just check the comments because I feel like maybe I was rambly and you guys were like, girl, what are you talking about? Okay, nobody said anything. Cool. We're getting to the last 2 slides. So just like talking about some of the stuff, the decisions we made when we made this, is we use something called DHT. Oh my God, I already forgot what DHT is. We used to have this in when I worked in like a decentralized company. DHT, what is it? Distributed hash table. Yes, there it is. We use the distributed hash table. There was a couple of things that we did that didn't work out at first, and we had to like make a couple pivots. And I think like the main one we did when I say DHT, is we were putting every Git object in this distributed hash table. But then we were like, dang, this is actually mad slow. Like this is not working out how we thought, because it has to rebuild every single object. So instead, we just have inside of our DHT the repository ID. And then that way it could refer to like the repository ID that's in a particular storage node. And it can be like, okay, cool, I matched it to here, rather than it just storing all of that data and being like super duper slow for clones and stuff like that. And then the other thing was making sure we have replicas of separate infrastructure. So like I had mentioned before, if a node is down, you have a backup one that'll help you. And this is basically like everything I learned. I don't know if you guys thought this was like, but I thought it was like so interesting on like what happens with a Git push and how we were able to change it. And the 4 things that we ended up doing, just like as a recap, is we basically separated immutable history from moving branch pointers, aka we separated like commits, file trees, all of that data that you see when you're on your Git hosting platform. You're like, there's my file, there's my folder. We separated that in the database from branches so that those could be handled differently, some in distributed storage nodes, some in PostgreSQL. And then after that, we decided to have like custom push and read paths. We also decided to like replicate across the infrastructure before the branch moves, and we decided to give every repo a regional home. So that's kind of how we were able to build the Git hosting a Git hosting platform that's super fast. And that's kind of what I want to show. I can show you guys how to mirror a repo on your in Entire. Here's the easiest way. Maybe I will put it to, yeah, let's just stay here. Entire.io. So I'm gonna be in the UI right now, because you can do this from the CLI, but it's even easier in the UI. I think a little bit people get confused. And oh, I didn't even explain what mirroring is, right? So like I said, you could store your code on different code hosting platforms, different forges. But if you want to get the benefits of Entire, you might want to store your code on Entire, right? We're still building things out slowly by slowly, but we decided instead of making you have to switch completely over from GitHub or whatever platform you are in, because we know that's annoying. You can see me, I have 354 repositories right now. I'm not trying to like manually move all of these repositories over to Entire. It's just 345. It's not really helpful. It's not really fun. And it's just not attractive or appealing for me. So what we're saying is you could keep it on GitHub. Keep it if you want, but you could also do something called mirroring or syncing your repository from Entire to GitHub. That way you're able to get the benefits of speed and all that while still staying on GitHub. So the way I will find this is I usually look for, so I went to repositories, if people can see, and I'm going to look for, they change it every day. Filter. That's what I think I want to look for. Oh no. They did change this. All right, I'll just search my name. What I was looking for is this already mirrored or not, but whatever. We're going to use the same repo that we just did for the EntireDB Git storage talk, and we're going to just have that be mirrored. So here we go. As you can see, it's inactive. It's grayed out. That means it's not mirrored on our platform. That's what I was looking for. I was looking for the word inactive. But yeah, we must have changed this between last week and this week, but whatever. So I'll click it, and then the thing I want to do, right, is I go here and it tells me like, this is not mirrored. Do you want to activate this repository? Yes, I do. I'm going to press activate. And I chose the jurisdiction that I want this to be in. I live in the US, so I want this to be in the US. That's the closest place to me. And now it mirrored, it told me that it's active, great. And the next thing that I would need to do to be able to start tracking my checkpoints, or I should say, tracking my session data, my transcript, my prompts and all that, is I would install the CLI, I would log in, I would clone, and then I would say entire enable to make sure all of that works out. I'm not going to add too much more to this repo, I don't think. So there's no point in me doing that right now, but I could show you what it looks like when there are checkpoints being tracked. Let's see. What is one that won't expose my entire company and get me in trouble? Here's one. This is one that I have myself. So I could see the different sessions that I had. I could see like, oh, cool. I started talking with Claude Code, or Codex. I used GPT 5.5 or whatever. Here's the prompts that I did. Here's the response that it gave back to me. I could even see the tool calls if I needed that. But yeah, that's how you'll be able to like see your sessions, your checkpoints. And the thing is that when I show people stuff like this, you can see the amount of tokens you use, the files that got changed, whatever. When I show people this, they're like, I wouldn't be reading through my whole transcript. Yeah, duh. I don't read this transcript. I ask my agent stuff. Like, I'd be like, why did you add this change, or when did I make this decision? And then it'll go through my checkpoints because it has that data as a reference point, and it'll tell me like, oh, here's why we made this decision and you might have forgot. So that's really all I wanted to show today. Let me see the comments. Love the CLI. Nice. Yeah, you can do this through the CLI. You can do this through the UI. I'm definitely like a bit of a UI desktop app girly, just because I think it's easier to see. But of course, you need the CLI to start tracking stuff. So I could have also just ran this in the CLI and seen what it was tracking and what it wasn't. But that is it for me. Next week, I'm going to try to do something more interactive and not necessarily just like a slide deck of walking through things. But this is also helpful for me because I want to be able to um like word what I've learned, because this is a whole new way of thinking, not just for you guys but for me as well. So I'm really trying to like learn, like, how do I say some of this stuff out loud? Does some of this stuff make sense? If you guys have questions, let me know. Let me see, there's a new comment. It's really good for understanding what happened. Exactly. I think an issue that's come about now with AI is like, yeah, it's producing code mad fast, a lot of code, but now we don't really know like why it produced that code. And you might be like, why would I need that? For example, I maintain like open source projects, and then I get like a file, like a PR that has like 75 files changed. And I'm like, dang, it kind of looks right. I don't know. I wish I could see what prompt you did, stuff like that. And that gives that insight for me as a maintainer on, oh, okay, here's how they approach the problem, and it gives me a little bit more confidence. Or on the other side, let's say I made a change, even back in the day when it was just me manually coding, I would not remember why I made a particular change. So being able to go back and look at it and be like, oh yeah, that's why I added it, or that's what's impacting this, that's why there's a bug, is really, really helpful. So adding that semantic memory layer, I think, is really underrated. All right, y'all, that is all I have. I hope you have a great Monday. Have a good day.